Hello Finance 3720 students. Today we will talk about the options. We will continue our discussion from the last class. Last class we talked about put call parity, and put call parity is used for two purposes. The first one is to create synthetic position, or to create synthetic asset. So let's say I want to create long short, or I want to create the short put position. And the second purpose for put call parity is to explore potential arbitrage opportunity. So basically what it means, let's say we calculate the value of a put option. Let's say that the value of the put option using the put call parity, and let's say that the value of the put is $3.74. Okay, and let's compare the value that we got from the put call parity to the actual market price. Let's say it's $3.48. Okay, so the value that we got from the put call parity will be the theoretical value, while the $3.48, which is the actual price right now, is the market price here. Okay, and if the theoretical value is less than the market price, that means that the price right now is too high. So that's why, if this is the case, this is overpriced and we want to sell the asset. In this case, we want to sell the put option. But let's say if the theoretical value is greater than the market price, that means the asset that we have, the put option that we have, is underpriced and we want to buy because it's underpriced. Then we want to buy. So that's basically the two purposes of the put call parity. Okay, so now let's continue with the binomial option model. So binomial option model. Remember that option is a secondary asset, basically. That's what I like to call it, a secondary asset. And what does it mean? That means that or derivative asset. What it means is simply that the value of the option, value of option depends on the value of the underlying asset. Value of underlying assets. Of course that we have learned different kinds of assets, like the stocks, the bonds, or we can also talk about commodity. So in this case, let's say that we are going to use the stock option. So the option on the stock, the value of the option will depend on the value of the stock itself, the value of the underlying asset. For example, let's just use the call option. Remember, there are like two types of options: call option and put option. All right. What happens if the stock price goes up? What happens to the value of the call option? If you remember from our discussion, you should know that the value of the call option is also going to go up as the stock price goes up. And that's simply because call option gives you the right to buy at a pre-specified price. So if you are, let's say, allowed to buy a stock at $30. As the stock price goes up, your profit is going to get bigger because you are allowed to buy more expensive asset at $30. But on the other hand, if we have a put option and we have a stock price here on the other hand, as the stock price goes up, the value of the put option will go down because it's getting or it's becoming less and less profitable for us like to exercise our put option. So now the question is, how do we calculate the value of the option? Remember from the put call parity? From the put call parity, we calculate the price of the put, the price of the call option, right? Or the price or like the value of the stock. We calculate that. Now, how do we calculate the price of the put option or the call options if we are using like a simple model? So in this simple model, we just assume that stock price can only take two possible values, okay? Going up or going down. So that's why it's usually called the binomial option pricing model. Because when we talk about binomial, we have bi, and that means two. Nomial means that there are two nodes, so there are two possible scenarios, option pricing model. In reality, in practice, we know that stock price can take or can change into so many in unlimited number of possible values. Let's say today the price of the stock is $35. The next period, it could be tomorrow or it could be like next hour, the price of $35 can change to anything theoretically, right? It could go up to 35.01, it could stay at 35.00. It could theoretically, it is still possible, even though it is unlikely, it could go up to $1 gazillion, right? Or it could go down like to zero. But basically what I'm trying to say is that the value of the stock can change from one period to another period, and there are so many unlimited number of possibilities. So that's the reality. But if we want to calculate the stock option using that model, where like the stock price, the value of the underlying asset can change to anything, it is so much complicated. So we will start with the simplest model, which means that there are two possible scenarios. The stock price either go up or either go down. Okay? All right. So let's use an example. So let's say that the price of the stock right now is $30. And let's say that the exercise price of the stock option is $35. Okay? And let's say that you have the interest rate here is given, let's say it's 6%. Okay? And we're also given that the information that the maturity of the call option here is 6 months. Okay? All right, so let's calculate the price of the call option. We want to calculate the price of the call option. Okay? All right, before we continue, I also need to give you another piece of information, which is the multiplier. Okay? Remember the stock price, $30, can either go up or down. So there's got to be like a multiplier here. Okay? A multiplier. So $30, if it goes up, how much it's going to go up to? And if it's going to go down, how much it's going to go down to? So we need a multiplier here. So that's why I'm going to give you like the U and D. U is the multiplier, the upward multiplier. So let's say in this case, I'm gonna give you 4/3. Okay. How did I get like the 4/3? I just made it up. As long as the u is greater than 1, you can use any numbers that's greater than 1 for u. Because remember that we want the stock price to go up. So that's why the multiplier has to be greater than 1, right? If the multiplier is only 1, it's not going to be this, it's not going to be bigger. In fact, like, you know, if you multiply times 1, $30 is going to be $30. So it's not going up. So here I'm just like I just pick like a number. Let's say it's 4/3, and D. Once you have like the U, and the U will be given. Once you have U, D is simply 1 over U. So we can calculate it. It's 3/4. Okay. So now the multiplier, the upward multiplier is 4/3, and the downward multiplier is 3/4. So you multiply 4/3 times 30, you have $40. And here, the multiplier for downward is 3/4. So you multiply 3/4 times $30, and you should get to $22.50. Okay? So, let's recap. This is the stock price today, and one period from now, you will know that the price is either $40 or $22.50. That's the value of possible value of the stock of one period from today. Okay? All right. So now let's continue. So this is $30, this is $40, and this is $22.50. Okay? So now I want you like to pay close attention here. So once you have like the value of the stocks between now and one period from now, now we can move on like to calculate the value of the call option at all nodes. Okay, we have 1 node, 2, and 3. Okay, so in that case, we will start from the right to the left. When we talk about like the value of the stock, we move from the left to the right. But when we talk about the value of the call option, we always have to start from the right and then we move backwards. Okay? So now, what is the value of the call option here and here? If from the previous problem, we know that exercise price is $35. What is the value, the call option, if the stock price takes a value of $40? Well, remember, this is call option. So the value of the call option is the maximum between 0, S, comma, S minus X. S is $40. X is $35. So that's maximum between 0 and 5. Which is bigger, 0 or 5? It's 5. So the value of the call option is 5 right there. And we will do the same thing here. The maximum between 0 and S minus X. S is $22.50 minus X is 35. So it's gonna be 0, the maximum between 0 and negative $12.50. Okay, negative $12.50. Let me refocus. Okay, negative $12.50, which is bigger, 0 or negative $12.50? 0. So the value of the call option at the downward node is 0. Okay? Now, so I'm gonna draw the value of the call option. The value of the call option is 5 here, and this is 0. Okay? Now, once you have the value of the options, now the next step is to calculate the probability. What is the probability that the stock price is going to go up? And what's the probability of the stock price is going to go down? Remember that there are only 2 possibilities in this model, going up and going down. So the probability of up plus the probability of going down has to equal 100% because there are only 2 possibilities, right? That's why it's called binomial. If I want to use trinomial, let's say it's going to go up, flat, and go down. The probability of up, the probability of flat, probability of down, add them together, that has to equal to 100%. But in this case, because this is binomial model, so the sum of the probability up and probability down has to equal 100%. Let's call that the probability of up is pi u, and the probability of down is pi d. Okay? Pi u, the formula for pi u is simple. It's 1 plus the risk-free minus the downward divided by u minus down, u minus d. Okay? From the previous page. Remember that u is always greater than 1 and d is always less than 1. So that's why u minus d has to be positive number. On the other hand here, for the numerator, 1 plus rf minus d, 1 minus d is positive number because d is less than 1, plus rf is also like a positive number, so pi u has to be positive number. And pi d is really simple. It's 100% minus pi u, or that's also 1 minus pi u. This is pi d. Okay, let's calculate it. So pi u is 1 plus the RF. RF is 6% minus d. D is 3/4, and this is 4/3 minus 3/4. Okay, let's calculate it. So 1.06 minus 0.75, that should give you 0.31, and 4/3 is 1.33333 minus 0.75, that should give you 0.583333, and then next is 0.31 divided by 0.583333, should give you 0.5314. Okay, 0.5314. So if pi u is 0.5314, then pi d, simply 1 minus 0.5314 equals 0.4686. Okay? All right. So I'm going to take a break here, and I'm going to change my marker, and then I'm going to continue. All right. So now I'm just going to redraw everything again. This is the value, the option is $5. The value, the option at down node is 0. Think about it for a second. Now, there is probability of pi u that the value of the option is going to be $5. There's a probability of pi d that the value of the call option equals 0. So we can calculate the expected value right there. Okay? It's the same thing as this. Let's say there's a 70% chance that the rainfall is gonna be 10 inches. Okay, tomorrow, let's say 70% chance that there's it's gonna rain 10 inches tomorrow, and 30% there's no rain at all, so 0 inch. Okay, so what is the expected value? If you have this information, 70% chance you get like 10 inch of rain shower or rainfall, and 30% chance there's nothing. So if that is the case, you multiply the probability. Okay, what is 70% times the 10? It's 7. What is 30% times, just forget about inch here. What is 70% times 10? 7. 30% times 0 is 0. You add them up, you get 7 inch. So tomorrow, I expect that the value, or expect that the rainfall is going to be 7 inch. That's going to be the same concept here with our like call option. Okay, there is a 53.14% chance that the value of the call option is going to be 5. And there's 46.86% chance that the value of the call option equals 0. So what is the value? What is the expected value? The expected value of the call option 1 period from today. Remember that this is today, this is year 1, or 1 period from now. What is the expected value, expected call option, value of call option 1 period from now? Well, you just multiply 5 times 0.5314 plus 0 times 0.48 or 4686. Okay? If you do that, let's calculate. Then you will have 0.05314. Then you have 2.66 or 657. Okay? The expected value of the call option 1 period from today is 2.657. Let me double check. I'll multiply. Okay, so it's 2.657. Okay, so 5 times, yep, it's 2.657. But that is the value. This is time 0, this is time 1. At time 1, the value of the call option is 2.657. What is the value of the options today? And that is just like a regular time value of money problem. So if this is like, if the cash flow is 2.657 a year from now or a period from now, then the value of the asset today is just 2.657 divided by 1.06. Okay, 1 plus the risk-free rate to the first power, because it's 1 period. So I'm gonna and that should give you 2.506, and that is the value of the call option, the value of the call option today if we have like a 1 period binomial model. Okay, all right, so I want you to do this problem. Let's say that do another question. So let's say S is let's say stock price now is $25. Okay, let's say U is 5/4, and let's say that RF is 8%, and let's say maturity is 3 months. Okay, oh, you know what, I'm sorry guys, let me take it back. Let me go back to this. So even though that this is time 0 and this is time 1, okay, time 0 and time 1, I'm sorry, you don't divide it by 1.06 to the first power, because the length of the contract, the length of the option here is only 6 months, and 6 months in the annual year, in the annual term, is 1/2. Okay, so I need like to change that. Sorry about that. So 1.06 raised to the 0.5 power is going to be 1.02956, and this is 657. So now 2.657 divided by 1.02956, and you should get 2.58. and that's the value of the call option. Okay, so don't forget about the compounding here. This is not one, even though this is one period, but this is kind of like one period equals like 6 months. So I need like to raise it like to the 1 half power. Okay, so now let's do another problem. Let's say the stock price is $25. Risk-free rate is 8%. Okay, risk-free rate is and let's say this X is 28. Okay, and I want you to calculate, let's say that this is a one period model. Okay, so I want you like to do it. Stop the video now, and then let's compare like the calculation. Okay, all right. Okay, now that you are back, let's calculate the value, the option. So as usual, I'm gonna draw like two diagrams. The first is for the stock. This is 25, the value of the stock, and then I will multiply it times 5/4, and this is 4/5. Okay, so 5 divided by 4 times 25. I'm just gonna write it down here, 31.25, and then 4 divided by 5 times 25. I get $20 right there. Okay, that is the value of the stock, $31.25 and $20. $31.25 and $20. Okay, I also need to know pi u and also pi d. Pi u is 1 plus RF minus d divided by u minus d. 1 plus RF is 1.08 minus d. D is 4/5 divided by 5/4 or minus 4/5. Okay. All right. So 1.08 minus 0.8, 0.28, 1.25 minus 0.8, that's gonna give me 0.45. So 0.6222. Okay, so if pi u is 62.22%, then pi d is gonna be 37.78%. Okay, all right, so the value of the stock is gonna be 31.25 and 20. Exercise price is 28. So the value of the call option here is going to be $3.25. The value of the call option at downward node is going to be 0. Okay? So what is the expected value there? So multiply the probability times 325, the probability up times 325 plus probability down times 0. So that's going to be 325 times 0.6222 plus 0 times 0.3778. Okay, and if you calculate it correctly, then you should get 3.25 multiplied times 0.6222. You should get 2.02215. Okay, next what I'm going to do is, if the expected is 2.02215, this is 3 months from now. Okay, 3 months from now, and this is right now. What is the value right here? Well, that's pretty straightforward. So I'm just gonna divide 2.02215 by 1.08 to the 1/4 power. Okay, and I'm gonna get 1.08 . It's 1.019426. And this is 2.02215. 2.02215 divided by 1.019426. So you should get 1.9836 right there. And that is the value of the call option 3 months from now. I'm sorry, this is the value of the call options today. If the call option is 3 months long and exercise price equals 28 and the risk-free rate is 8%. Okay? Alright, so now I'm gonna expand. I'm gonna expand the 1 year or like the 1 period model into 2 period model. Okay? From 1 period model to 2 period model. It's still the same concept. So let's say RF equals 8%. RF equals 8%. Let's say S equals 25. It's 3 months. U equals 5/4. X equals 28. So we're gonna do this. So right now, so let's say that right now is $25, and it can go up, it can go down, like that, right? So this is 0, this is 1, this is 2, or this is not period 1, but this is 3 months from now, and this is 6 months from now. Okay? So what happened if we have this? So 25, we know that this is 5/4. This is also 5/4, like go up, up, and then go up is 5/4, and this is 4/5, going back, and then this is 4/5, 5/4, 4/5. Okay? So 25, this is 31.25, and this is $20. Okay? What is $20 times 5/4? It's going to be 25. So it's going to go down and go up, and that's going to give us like back to $25. The down here is like 16, and then the up 31.25 times 1.25, and you should get 39.0625. Okay? So whenever you deal with the option pricing model, you always take care of like the price of the stocks first at all nodes. Okay? So this is the initial node, this is the up node, down node, this is up node, this one is up down or down up, and this one is down down. Okay? So you calculate all the value of the stock. All right? Okay, so let's continue. As I said, I'm gonna draw the option, the value of the option now. Okay? The value of the stock at the upper node is 39, like that, right there, 39.0635. 39.0635. Remember that the exercise price, I'm sorry, 0625. 39.0625. That's the up node. So 39.0625. The exercise price is 28. So the value of the call option here is 11.0625. Here is $25. The value of the stock is $25. Exercise is 28. So that's going to be 0, the value of the option. And here, the value of the stock is 16. So here is also going to be 0. Okay? So now, what I want you to do is, I want you to calculate the expected value between two nodes. This is between, so now you have 1, 2, 3. If you have three possible call values, then you can calculate the two expected values. So one expected value is always between, like, two values. So what is 110625? And this 0, this is 0. Remember that the pi u, we need pi u. Pi u is, where is that at? It's 62.22. And pi d is 0.3778. Okay? So what is the expected value right there? So it's 110625 times 0.62222 plus 0 times 0.3778. And here, because this is 0 and 0, so the expected value has to be 0. Okay? This 0 and 0, so expected value equals 0, because 0 times 0.62222 plus 0 times 0.3778 should give you 0. Okay? So let's just move like our calculation here. So it's going to be better for you to look at. This is, you multiply 11.0625 times 0.62222. Okay, so 11.0625 times 0.6222. That should give you 6.883, and this is 0. Okay? So next, what I'm gonna do is this. I'm gonna discount it back one period, 3 months, right? 3 months. So this is gonna be 6.883 divided by 1.08 to the 1/4 power. This is 0 divided by 1.08 to the 1/4 power. Okay? And if I do that, 1.08 to the 1/4 power, it's 1.01942. 6.883. This is 0. 6.883 divided by 1.019426. You should get 6.7518. And this is 0. Okay? All right. So this is going to be 6.7518, and this is going to be 0. Okay? And that is from here, guys. 6.7518, and this is 0. And I just like put it on a new piece of paper, so that's going to be easier. And then you calculate the expected value. So 6.7518 times 0.62222, 6.7518 times 0.62222 should give you 4.2009. And then we will discount it back 3 months. So I will divide that by 1.08 to the 1/4 power. So that's going to be 2009 divided by 1.019, 426. Okay, divided by 1.019426, and that should give me 4.12 right there. Okay. All right. So that is how you do the binomial option pricing model for call option with 1 period and 2 periods. Okay. All right. So the last one that I want to talk about is this. How about if we talk about the call option? Well, it's going to be the same thing. Let's say S equals 25. Okay. S equals 25, RF equals 8%. It's 3 months. U is 5/4. X equals 28. We also calculate pi U is like 0.6222, right? But now instead of like calculating the call option, let's calculate the put option. So the way you do it is this. Like usual, start with the value of the stock. Okay, the value of the stock. So this is 25. For the 1 period, it's going to go up to 31.25, and this is going to go down to $20. Okay, and why? Because you multiply times the multiplier, the upward multiplier, which is 5/4, and you multiply times the downward multiplier, which is 4/5. You got like $20 right there. Okay. All right. So once you have that, again, I will calculate the value of the call option. 31.25, and this is $20. Okay, what is the value of the put option here? What is the value of the put option there? The value of the put option here, exercise is 28. Okay, exercise is 28. If exercise is 28, then the value of the call option at the put option is 0. If the stock price is 20 and the exercise price is 28, then the value of the put option is going to be $8. Okay, so 0 and 8. Now we need like to calculate the expected value right there. So the expected value is going to be 0 times 0.6222 plus $8 times 3778. Okay, so 0.3778 times $8, you got 3.0224. Discount it back like 3 months back, so you get 3.0224 divided by 1.08 to the 1/4 power. That's going to be 3.0224 divided by 1.019. 019. What is the 426? Right there. Okay. Divided by 1.019426. And you should get 2.9648 right there. So the value of the put option for 1 period is 2.96. Okay. So I want you to for the practice, I want you like to do the calculating the put option for 2 periods, 3 months and 3 months. Okay, calculate the value of the put option. All right. If you want, you can send me, you can email me like the your work, and I'll take a look at that, and I will check it for you. I will check that for you, and I'll get back to you. I'll be happy like to check your work and make sure that you're on the right track. Okay, guys, that's it for today, and I will see you next Tuesday. Okay, bye-bye.